Hello, greetings everyone. Welcome to another Splunk Tech Talk. We'll be waiting for everybody to join for about a minute. So I'll just wait a little bit. Hello, if you're joining, we're waiting for everybody on the list to join. In about a minute, we will start our Tech Talk. So please just all right, maybe 30 more seconds and we will start. I can see a bunch of people joining. That's lovely. See, greetings. Okay, I will start real slow and we'll see if somebody joins in. It's vacation time. Lots of people are resting and doing something interesting elsewhere. Welcome again to Splunk Tech Talks. We're very happy to have you here. My name is Gregory. This one is called Splunk Cloud Application Management in Terraform. So just a little intro about me, I guess. I'm a product manager at Splunk. I work in the application platform, specifically application deployment team, and we're focusing on Splunk apps and the ways to manage them. Doesn't really matter if it's cloud or on-prem, but in this specific talk, we'll be focusing on the cloud offering and cloud part of this capability. My background is very kind of platformy. So before being a product manager in other companies, I've had mostly DevOps architecture-based career. And yeah, this has been the area in which I specialize. So this talk is in a way a distillation of many years of practice. Okay, great. So I see more people are joining. Welcome everybody to the Tech Talk. We're just joining, so you haven't missed much. Just introduce myself and let's talk about what we'll be talking today. So I will try to make this as universal of a presentation as possible. I know that a lot of you have very diverse skills. Some of you are experts in some parts of the presentation. So I will try and cover some basics first, and then we will go progressively into more kind of complicated topics as we go along. So I will introduce the general ideas about what is infrastructure as code, what are declarative and imperative paradigms, what is Terraform in general sense of the word, and then we will eventually realize towards managing Splunk applications with Terraform. Sorry, I'm just gonna check something. Okay, I'm with you. Okay, so let's start with just a little warm-up questionnaire. Please select an option on the screen. Do you have any Terraform experience? And the options are vaguely expert, beginner, or non-experience, like never used Terraform before. It will help me to also kind of adjust this talk and the content of it. About 30, yeah, half of the attendees have attended so far. So just a little bit more, and we'll have ourselves the answers. Great. Okay, beginner 75%, none 25%, and no experts. Good. So this will be interesting to most of you. I will not be covering some completely boring stuff. All right, let's start with declarative versus imperative paradigms. So to sort of set the stage for Terraform and general infrastructure as code, we first can define that imperative paradigm tools or languages describe how to do something in terms of actions or verbs, right? So create a file, run a command, execute a command, perform an action. Declarative paradigm describe what results do you want. And the automation, whatever it is, a language or tool like Terraform, is figuring out how to kind of reach that end state. Sorry, somebody is asking, am I sharing the screen? I think I'm sharing the presentation, so you should be seeing a white page with some text on it. You see the presentation. Okay, cool. Thanks a lot. Thank you. My colleague will answer all the questions. So I will proceed with the talk. All right. So with imperative paradigm, you are saying what are you doing, and with declarative paradigm, you kind of describe the results and the outcomes. Most of you probably have used ACS CLI to control Splunk cloud instances, and on this spectrum, I would say that it's mostly imperative, right? So restart of the stack is an action. It's a verb. That's definitely imperative. Creation of apps, users, or hack tokens, or any other resources are all kind of declarative because you're saying, like, I want the app to exist, but the CLI lacks global shared state, right? So if somebody somewhere else in your company is also installing an app, creating a hack token, doing any other thing ACS allows you to, there is no shared state between you. So you're not necessarily aware of what that person is doing. What is infrastructure as code? It's a pattern to manage infrastructure through files rather through manual actions of any sort. It doesn't have to be the user interface. Sometimes people say ClickOps, meaning like clicking with the UI in the browser, or using the CLI of various kinds, right? So infrastructure as code is a concept, is an idea to manage your infrastructure in a different way, not in a way that requires these actions. There is old saying that in data center you need 2 of everything, but in cloud you need 20 of everything, and that's like obviously it's a joke, but in a lot of the sense, it's describing kind of truthful sentiment, because in cloud, complexity really explodes. So there's usually lots of things that you need to manage, and that complexity honestly just keeps growing, right? So the average Splunk stack, I would say the mean rather amount of applications in the cloud stack is about 50-ish. We have clients who have less, we have clients who have way more. But even with 50 applications, it's quite a lot to manage, right? All of them have lots of configurations, lots of options to deal with. There are lots of scenarios that you can be interested in managing as an admin. So infrastructure as code is kind of like an answer to this specific problem space. Storing configuration in CI/CD pipelines has a number of advantages, some of which are like hard baked into this idea, and some of them are optional. So like you may achieve that result if you put in the work, or you might not if you don't. So auditability is pretty much baked in, which means that if you manage your, we're talking about Splunk Cloud, so if you manage your Splunk Cloud from infrastructure as code solution, it means that everything you've changed is stored as code, and it's usually stored in Git. So that gives you auditability. You can see everything that everybody has ever done on your account, when they did it, in which context, which sequence, and that's basically external audit of your instance. Compliance, lots of regulated environments such as SOC 2, HIPAA, and others basically require auditability plus rigorous controls, right? So it's more of the same. You always see what has been changed, where it was changed, by whom, and you're able to tune in these access controls to the repo where you store your code, and have that adjusted to your compliance, to your team's structure or organizational structure that you're operating. Access controls, again, kind of developing the same idea. GitHub Actions, GitLab CI, Jenkins, or whatever other CI/CD platform that you're using allow you to operate with branches, and they allow you to operate with environment variables, usually kind of baked in with the concept of branches. So that's smaller ability to make a mistake, or smaller area to leak your secrets if they are leaked, because they are they're scoped to the branches, and they're usually correspond to like dev staging prod environment in your organization. Optionally, you can just not store secrets in source code at all. This is optional because you're in control of what you're storing in your repository, and you might put secrets there. I will have a slide about it a bit later. That's highly unadvisable, but it's essentially up to you. Few other things that storing configuration in CI/CD allows is reproducibility. So if you want to install 50 applications of certain versions on one stack, and then you want to repeat that, if you're using any other approach other than infrastructure as code, you're in for a lot of work. And if you make one mistake, if you forget something, you're not careful or distracted or something of that nature, you're going to arrive at exactly the same reproducible environment. That's all basically up to you. The pressure is on you as an admin. With CI/CD, you can recreate thousands and thousands of environments exactly the same way, because you're all feeding from the same template, as it were, right? Rollback simplicity means if you're managing your apps or hack tokens or anything of that nature as infrastructure as code, and you've defined the list of apps and their versions, and everything is working, then you're introducing a new app and it's breaking. Again, by the nature of storing files in Git, by the nature of source control, you have the latest working version stored there. So restoring your Splunk stack becomes essentially as easy as doing git revert, right? So like all you need is to go back a commit and have yourself a completely working environment again. There are two more optional benefits that are again optional to you depending on how you write your infrastructure as code and um, which solution for it are you using? There are separation of concerns and environmental parity. So separation of concerns means that you don't have to have one huge file that describes everything in your Splunk stack or even everything in your control as an admin of probably more than Splunk. You can separate it into different files, and solutions such as Terraform allow for almost unlimited complexity of nesting, making modules. So like you can select Splunk into a separate module. You can select different teams in the organization that are using Splunk. So your DevOps team being a separate module, and then your security team or fraud analysts being a separate module and whatnot, right? But you have to code that, right? That's entirely up to you. Terraform is a language which allows you to express that idea rather. Environmental parity basically means that should you want to have dev staging and prod be the same, you can achieve that outcome, but again, it's up to you. If you're coding your Terraform manifests in a way that allows that outcome. But this is a powerful tool because it allows you to reduce the complexity and reduce that problem that every one of us has seen lots of the times is, well, it worked in dev, uh, it um, it worked at dev, it stopped working in staging, or I have my application that works fine. I tested everything I could in dev and staging, then I graduated it to prod, and all hell broke loose. My instance stopped working, or something unexpected started happening. All right, cool. So let's start talking about Terraform. Terraform is one of the most popular solutions for infrastructure as code. It's developed by HashiCorp. Now HashiCorp is part of IBM. HashiCorp are authors of some very well-known tools such as Packer, Vault, Consul. They're all very well regarded and very popular if you look at their repositories on GitHub. Terraform uses its own .tf manifest format to define what kind of infrastructure are you creating, and then using that, as we discussed about what declarative paradigm is, it uses that definition and then aligns your infrastructure with what you just said you want. Teams, especially distributed in geographically around the world, can manage resources and have the state of all those resources all be stored in distributed, highly available storage, such as S3, Console, Kubernetes, or Terraform Cloud. We will explore that idea. I'll show you how that looks in practice. Just a little bit there. So we're arriving at kind of the meat of our story here. Terraform for managing Splunk Cloud applications. On using the URL on the screen right now, you can access a provider for Splunk Cloud platform for Terraform, and it has a bunch of resources. So a provider is sort of think about it as a library in any language. and resources are sort of like functions inside of a package, right? So things you can do with this provider include hex tokens, creation and managing of hex tokens, indexes, IPLL lists, roles, users, and we have very recently have added Splunk base and private apps to the mix. So that's the example definition of how one creates an app with this provider, and I'm going to walk you through some practical scenarios about like how are we going to actually do this, right? So the challenge that we're going to set for ourselves, I didn't want to really have this demo about like, hey, let's create, let's install, a no-name private application that tells you nothing. What I want to achieve here is I want to leverage Splunk base. I want to use my GitHub account, and I want to have Terraform control it all and like tie it all together into one integrated detection and log processing use case. So we will start by going to Splunk base, and we are looking at Splunk add-on for GitHub. This is an application written by Splunk, by my colleagues here in Krakow. Thanks a lot for their help on this app, and we're going to use it. We're going to install it with Terraform, and then we'll configure it and see how it works. All the code that I will be showing from now on, it can be seen in the repository. The link is now on screen. You can follow now, you can come back later. So I tried to make this as step-by-step as possible so that you can basically select the level of complexity to which you want to go, in which you're interested, and repeat whichever steps that we're going to discuss now in your Splunk Cloud environments. Should you have any questions now or in the future, this repo will have issues open. So if you have any questions for me about any of those files, please feel free to raise issues there. If you're comfortable with GitHub issues process, you can continue asking questions and Q&A as we go along. So just a little announcement, I guess. Let's start then. All right. So in that repository, you will see, I think, 5 files called example 1, 2, 3, 4, and 5. And those are not the things I want you to do in production, especially this one, right? We're starting as simple as possible. This is the simplest, smallest possible Terraform manifest. There's plenty of bad things about this. And remember when I said that it is optional for you to not bake your secrets into your definition of your infrastructure as code? Well, we're doing exactly that here, right? So to create a Terraform definition, you need to select the provider first. So the first 7 lines is just telling Terraform that you want to basically operate on Splunk provider. You want to do something with Splunk Cloud. The version, there are different versions at any given time, so you need to pin the version that you're using. Then from line 12 to line 19, we're configuring that provider. So we're feeding it information that allows it to connect to Splunk Cloud. And here I just baked my completely fake credentials for Splunk and for Splunk base into this definition. If this code were to be leaked, or for example, like I'm sharing this repo with you, like if I put my actual credentials into this thing here, it would be very bad because I would have just leaked my production access to the world on GitHub. That's not very good. There are other problems about this particular code, and we're going to like quickly see something better. But you could run this. This is a legal Terraform definition that you can do. put into the file, run Terraform init, Terraform plan, Terraform apply, and it would work. But let's do something a little bit better. So Terraform has this concept of variables. Basically, everything that was hard-coded in the previous slide, we're defining a variable blocks, like variable stack name, variable SCP password, variable Splunk username, and stuff. You need to give them a type. All of these are strings. Description is really there for you. It's not optional, but content is optional, so it's just for you to remember what it is. And we're going to pass all of these variables into the provider block with var dot, for example, var dot scp password. Right. This means that when you run this definition, Terraform will be looking for .tfvar file that kind of goes along with your file at which we're looking right now, and you're decoupling your variables and secrets in those variables from like the blueprint of what you're doing with your stack. You can be seeing some problem here as well, right? So we're looking at two resources for the Splunk-based application for user in SCP stack, right? There is a lot of repetition here. There's a lot of repetition. These two, this is a user that is meant to be accessing the Splunk TA application once it's installed, right? Like you're installing the application, then you're provisioning a user that will be using that, and you're giving them certain access to certain indexes, for example, that operate in the application you've just installed. So there is a logical connection between the two, and there's a lot of text on the screen right now, or like Splunk TA GitHub variable in Splunk base app resource in the name, and in SCP user default app parameter, it's the same text. If you make a mistake in one of those, it will not work well. So you need to track a lot of the same text, right? You can see where we're going with this. We can use a variable. So you can use baked-in Terraform awesomeness such as variables. So you see that in Splunk base app resource, the name is still a string literal Splunk underscore TA underscore GitHub, but in the SCP user block, in default app parameter, I'm no longer repeating the same string. I'm saying SCP Splunk base app dot name, and it just goes kind of up in the tree of resources is where and accesses it from elsewhere, right? So no longer I have the need to repeat that string, and if I'm making a change in it in the resource Splunk base app, it gets changed everywhere else. Additional benefit of this approach is that Terraform automatically infers a dependency, right? Because you are accessing something in a different resource, Terraform in the apply state, which I'll show you in the next slides, will figure out that, hey, I really need to make sure that the app is installed first, and then I'll need to create the user. So that's kind of one of the benefits that Terraform gives you, and it doesn't necessarily know the details about Splunk or Splunk-based apps, but it would work the same way for any other resource in Splunk Cloud Provider or not. We can even do this. We can even define a block called locals and define a bunch of local variables that will be reused in a bunch of different resources down the line, right? The only difference here, you can see that the name is now referring to the local variable, and the default app refers to the same local variable. You can obviously repeat that with versions and Splunk-based IDs and all sorts of things. The only caveat here is that the dependency that we had in the previous slide now doesn't necessarily exist because we're not referring directly from SCP users resource to SCP Splunk base app resource. So if you want that, conditional creation, like the app has to be created first and then the user has to be created second after the app is completely finished installing and is working, you need to add the depends on clause and say within SCP users depends on square brackets SCP Splunk base app .github. By the way, about these names, so if you look at the resource SCP Splunk base app GitHub, the name for the application that you're installing here that will appear in Splunk in the UI of Splunk base in the UI of Splunk interface that you're accessing is what you provide to the variable name, right? So here it's local dot gh app name variable defined in locals. The literal on the line resource SCP Splunk base app GitHub is the name for the same thing, but in Terraform. So those two can be the same if you want to. It's just a little kind of technical difference. So you're if you change GitHub here to foobar or whatever, and reapply this this file, this Terraform definition, your app in Splunk, its name will not change. If you change the name parameter and we'll keep GitHub as it is, or we'll give it any other name, whatever you put to the name variable will apply to your Splunk, to the stuff that you see in Manage Apps page, your Splunk instance, basically. All right, so we have discussed how to write this code into a file that's like example1.tf that I have in my repo. And what do we do with that file, right? Like, how do we translate that into an app working on the stack? So once you'll notice that I transferred here to a directory called actually working directory. So it has only one Terraform file as it should be. The root directory of this repo, tf-techdog, has a bunch of files, and Terraform will be confused which one do I want to apply. I really don't want you to be running those because those are in bad form. So if you want to copy something and have something applied to your actual live stack, I really recommend you going to the actually working dir and go from there. And you can run a command called Terraform plan. You need to install Terraform. I just assume that you can go to terraform.io website and install it from there. Basically, you can use any package manager that you're running, like brew or anything else, and just go like brew install Terraform. Should be fine. DNF install Terraform will work as well. I'm assuming that basically you have Terraform installed in your machine. So to apply the file that we wrote in the previous slides, we're going to run Terraform plan command, and --var file means that, remember, we define a bunch of variables, so we don't want to hard code our password and secrets into our infrastructure as code. So we're saying run this file, but my variables, so the sensitive data that I don't want to be leaked, you will see that I have // so I have it two directories higher up the tree, right? I'm getting a error saying inconsistent dependency log file, right? I forgot to run Terraform init. So for the first time, when you're just creating your first run, you need to run Terraform init file, and it will create a bunch of files in the directory where you're running this. It will basically download things Terraform needs to work. And you will see a command with green text here saying Terraform has been successfully initiated. Now we can run Terraform plan. And the output of Terraform plan is as per our definition of what declarative, imperative versus declarative means, you're saying, I want to have a hack token, I want to have an index, and I want to have an app called GitHub, right? And Terraform goes and figures out which of these things he can it can satisfy, which of these things are possible to do. Some of these can be installed like verbatim, exactly as you described them. Some of the things here will be, as it says here, known after application. So like with creating of the index, you are saying, here's the name of my index that I want to create, or here's the name of my app, but its ID or other dynamic parameters will be known after Splunk actually creates them. So Terraform Plan doesn't do absolutely anything. It's a safe command. You can run at any time. It will compare what you have on your stack with the definition that you have just fed it in the your manifest file.tf. It will compare the two and say, to achieve this result, here's the work that needs to be done. Here's what I'm going to do now. To actually do that, you need to run Terraform plan. You might be interested what happens after you run Terraform init file. And if we list the files in our current directory, you will see that there is a .terraform hidden directory which has providers in it, and it's a bunch of nested folders which download everything this definition of everything this Terraform manifest needs to operate on, up to the providers, which are basically binaries precompiled for your architecture that you're running. So these files are going to appear here. You can delete them, but then Terraform stops working, so just don't. Okay. Yes, so we have written ourselves a definition. We have run Terraform plan. We know what it will do. You can repeat this. You need to repeat this command to actually create some files. You need to say Terraform apply in the same way like Terraform plan, Terraform apply -- var file, and your variable file. That will wait a little bit and go and actually create some applications or hack tokens that we have just defined. Let's add some data into the mix, right? So we have started by saying we have ourselves a challenge. We want to tie together a GitHub application, data from GitHub, our Splunk Cloud deployment, and have it all being managed by Terraform. So to do this, we need to add another Terraform resource, another Terraform provider for GitHub, and we're going to use the GitHub repository resource that will create a repo for me, and I just called it TF managed repository. So it just needs, I need something to happen in my GitHub repository for the GitHub TA app that we just installed to pick up something from the audit logs from my GitHub account. This is what I'm doing here. I got this definition from the Terraform marketplace. So from Terraform registry, the link is now on your screen. If you go there, you can find the provider for GitHub, or you can find the provider for many, many, many different other technologies, and repeat the same thing with basically different technology, different Splunk Cloud that you will surely find matching. So here we're defining our GitHub app, and let's actually apply that those changes too. Here you can see Terraform apply command in action. It says, okay, all this stuff before, you will notice that on the lines right after the Terraform apply command, it says Splunk base app.github refreshing state. Well, actually, it already exists, so there's nothing. We don't need to reinstall it again just because I'm running this command again. I can rerun this command 5,000 times. If everything has been installed in the first run, the other 400 whatever times, Terraform will just say, well, nothing to do here, and that's the intended way you use Terraform. you put it into CI/CD, and every time something changes, you rerun it. And Terraform gives you the safety that you will not reinstall, redo the things just because they're in a definition. Not to badmouth things like Ansible or other CI/CD tools, but stuff that is imperative in nature, such as Ansible. If you rerun it 5,000 times, it will recreate things 5,000 times. So that's kind of like a fundamental difference between infrastructure as code that is imperative and declarative. So yeah, our Terraform here says the app exists, the hack token already exists, the index already there, the user is already there. But hey, wait, you have just defined a new parameter, a new resource called GitHub repository, and here's everything that I'm just going to create right now because it's something new that you have just defined. We need to enter a value yes to agree with this being actually created, and Terraform will go ahead and start creating it. Hey, voila. After this has happened, we can open our Splunk Cloud. We can open the GitHub TA search page, enter the following search, and we have closed the loop. We're seeing the GitHub activity caused by Terraform creating a GitHub repo, and we are seeing it because we have configured Splunk add-on for GitHub as an app also with Terraform. It's a little bit convoluted, but it's also a little bit fun. It's a little bit of Inception in our own Splunk cloud environment. You can manage literally everything about your infrastructure with Terraform. You can use you can manage everything about your Splunk cloud deployment with Terraform as well. You don't have to, but you can. So this is a little bit of a convoluted example, seeing as you can literally have this nested complexity of different configuration of different things, all in one file if you want, or all in similar files all in Terraform. What else can we do? There are a bunch of tools that allow you to basically scan Terraform, scan your Terraform manifests for errors or misconfigurations, or provide you, think about it like any of your preferred programming languages will have linters, and like stuff like Rust has Clippy, or various tools that suggest you good practices. So in Terraform world, there are a bunch of these. One of them is called Chekhov. It's an open source utility that I'm not officially associated with in any way, but personally I find it quite useful. As you can see, if I run this against my example 5 file from the root of my repo that I shared with you, it will say, hey, your passwords are all high entropy strings, right? So those are just like common words that are very easy to attack with a dictionary attack. Don't do that. The other screenshot on this slide is Snyk. It's another company that I'm not officially affiliated to, but I like their service as well. You can scan Terraform definitions. Terraform definitions of Splunk resources are not supported, so you will never have any errors, at least for now. If you want that to be implemented, let me know. It's a cool thing that we are considering to build. But any other definitions of your cloud resources, like your AWS resources, your GCP resources, and such, can be seen in Snyk if you feed it your Terraform resources, and it will look kind of similarly. Yeah, it will say like on the line so and so, you have created a S3 bucket in an insecure way, or you have applied the policy that is too wide, or you hard coded some variable into IAC policy and stuff like that. So having, again, kind of coming back to the idea of infrastructure as code, having your cloud resources defined as text, essentially as code, allows you to use different tools to go over that code over and over and analyze it for mistakes, for misconfigurations, for things that can be done better and stuff. That is fundamentally impossible if you're managing everything by clicking the UI or running the CLI commands one by one. It's always a like one action in vacuum. So any system with any knowledge of like good practices cannot figure out what that action kind of corresponds to in a bigger picture of things. With infrastructure as code, it is possible. Okay, so I mentioned remote state, right? Like most of you on this call that I'm seeing are from very big companies who are surely geographically distributed. So another person that is managing, let's say, applications or hack tokens or indexes or anything else on your Splunk Cloud instance might be geographically not near you. You might not be able to talk to that person at all or at any given moment. So what happens if both of you decide to install GitHub app, but with different versions? Or what if you're creating something else that is like basically fights for resources? If you don't use remote state, whoever runs first wins. Whoever runs second will get an error saying like something's not right here. That error is fairly safe, and you will figure out what it means from Terraform. Is error messages are fairly good, but that's not the outcome you want. Like you would want to just know that stuff is happening and like not attempt actions that will fail. So remote state is basically answer for this. And for oh, I just dropped my laptop. The state of all of my apps that I've just installed was locally on my laptop, so it's no longer operational. I got myself a new one, but now I need to redeploy all of the apps on my cloud instance. That's not great. So if I store my Terraform state somewhere else, not on my laptop, but in some other system, all I need is just pull that state back in. It doesn't matter what I'm running from. Am I running from my CI/CD environment? Am I running from my laptop, from a server that my company has somewhere? All of this is fairly equal, right? So Terraform allows you to use different remote state solutions. You can store in S3, you can store in Kubernetes. I think you can store in like Postgres and Cassandra and some other databases. But we're going to use Terraform Cloud, which is another cloud service by HashiCorp. And I'm going to define a cloud parameter here. I'm gonna name my organization and give a workspace Splunk Apps staging to it. Enter HashiCorp Terraform Cloud. I would like to thank our partners at HashiCorp for providing us with the environment to run these tests. And yeah, Terraform Cloud is a paid service by HashiCorp that stores the state of your Terraform in cloud, so that your teams can all use centralized state of your Terraform provider, Terraform deployments, and much more, as I will show you in the next slides. So to do this, I need to use Terraform Cloud. I need to log into it, so I need to run Terraform login command. It will prompt me to open a browser and log into my Terraform Cloud environment. I have successfully done so. So here is a screenshot saying, hey, welcome to SAP Terraform. You have been authenticated. So now I can run Terraform apply again. And now when I run this thing, by the way, the code that I'm running right now is another repo, is another directory called now with remote state. So when I'm running this, you will notice that if you list the files in your working directory, there is no longer a Terraform state file. It used to be here in the previous examples because we didn't use the remote state. So like, where is the state? I've just applied some stuff, as we can see on the screenshot above. I've just like created an app and GitHub admin user and all these things. Where's the state? The state is in Terraform Cloud. If you open your Terraform Cloud page, if you navigate to the workspace that you have just defined, our workspace is called Splunk App Staging. You have a bunch of things here. I just wanted to quickly get your attention to the states page. So you see that the notable things about what we're looking at right now is it says my name, Rachet, _ Cisco triggered Terraform 20 minutes ago, right? So this is our synchronized global state. It knows that I have run this from CLI. It identifies the run. It records the Terraform version I run this with. There's also tags, so I have added like a staging tag to differentiate this from potential prod run again. And this is now stored in Terraform Cloud. So if my laptop goes away, if I change my laptop, if I change my working environment, I don't need to restart anything. I don't need to reprovision my applications. It's all here. There is lots of other functions that I encourage you to try out. Terraform Cloud is awesome. But that's basically what I wanted to draw attention to. There's also a run tab, so you can see every time you've attempted to run Terraform. And like right now, I'm trying to run another application of my Terraform manifest, and it's applying, so it's in progress. But you will see that you can see basically the entire history of your work. You can see the error, the running the successful runs before, and you can see yourself or your colleagues create things, which things they were creating or which things they were updating, whether they're Splunk apps or anything else. So that's about it. I want to finish on just like showing you the Terraform registry and the Splunk base. So both are these huge marketplaces where you can find pretty much any technology on Earth. We are offering lots of Splunk written apps, such as Splunk TA, such as GitHub TA for Splunk, that you can install from Splunk base. Use your Splunk Cloud deployment, go to manage page, click install more apps. You will see lots of these. You can select any technology pretty much that you want and quickly achieve the outcomes similar to what I've just shown you. In combination with doing the same thing with Terraform, you can have lots of different providers and resources for free from Terraform registry. In combination basically means endless opportunities. You can automate anything you want, and you can automate any scenario you could potentially want. It's a great area to explore, and we've just really scratched the surface of the possibilities here. So I hope this was useful and inspiring on your journey towards infrastructure as code. Again, all the links that I have just shown are in the repository that is now on screen. All the apps that you might want to install can be found in Splunkbase, splunkbase.splunk.com. The cloud Terraform provider is in Terraform registry under providers/Splunk/SCP for Splunk Cloud Provider. You can repeat all of the steps that we have just discussed in this talk by cloning yourself the repo and just retrying the steps there. If you have any questions, feel free to reach out to me. Obviously, feel free to use Q&A session that will start in a couple of minutes, but feel free to raise issues on my repo or drop me a line. That would be most welcome. So thank you a lot for your attention. Let's have a quick Q&A session. I'm going to look at the Q&A tab. Do any of you have any questions? I'm not seeing anything for so far. No questions. I don't know if it's good or not, but yeah. Let me just wait a couple more seconds. If nobody will come up with any questions, I'll just call out that you're welcome to join community.splunk.com to talk to any employees of Splunk. And I would like to shout out to next Tech Talks that will be given this month. There'll be one on August 6th about building and launching AI agents. And there'll be another one on August 20th about AI Toolkit, and also about building AI agents and more. So please be welcome to those Tech Talks and many others to come. Thank you so much for your attention. I'm not seeing any more questions, so I guess I'll be wrapping up this talk. Thank you so much, and see you around.